Hi, I'm Kashish, and right now we're going to discuss question 3 for homework 11 EL6303. What we've been told is that x of t is an input which is y10 stationary, and it is passed through um, h of t, which is an impulse response of an LTI system, and we get an output y of t. Now we have to find out if y of t is y10 stationary. We know that x of t is y10 stationary, therefore we can say that expected value of x of t is eta x of t, and we know eta x of t is a constant. And we know that this box here basically does a convolution operation. So the expected value of y of t is going to be h of t convolved with expected value of e of x of t, and that will give you h of t convolved with eta x of t. And then once you put the convolution operation into use, you're going to get eta x t minus alpha into h of alpha d alpha. This eta x t minus alpha we know is basically a constant value. It is not dependent on t because it is the expected value of x of t, which is y10 stationary, and therefore you can take out eta x and you're going to get minus infinity to infinity h of alpha d alpha, and this will again this will integrate to give you a constant. A constant into a constant is also a constant, and we know that it's independent of t. So the first criteria for being a White-Sun stationary process for y of t is satisfied. Next, we have to find r(y) of t, which is the autocorrelation, and we know that r(y) of t is basically r xy t1 t2 convolved with h of t1. So we say L1 rxy t1 t2. That means the system is operating on time t1. So rxy t1 t2 can be written as rx. So we are basically trying to find this so that we can insert the value here and get our answer. So you're going to get rxy t1 t2 is rxx t1 t2 convolved with h of t2. Now we are using t2 as the time instant that the function is operating at. Therefore you get rxx t1 comma t2 minus alpha h of alpha d alpha. And if you consider t1 minus t2 to be equal to tau, then you're going to get rxx tau h of tau convolved with h of tau. That is rxx tau minus alpha h of alpha d alpha, and once you put this in this, you're going to get ryy t1 t2 is rxy tau convolved with h of tau, and since it's dependent on tau, we know that y of t is White-Sun stationary. Thank you.